This conference will now be recorded.
All right. So, any questions, guys, from yesterday's session? Anyone? Any questions? How did we resolve the error that we got? Git config username and then the email ID. That's something that we need to do. Anyone who did not get that error? Anyone who was able to successfully commit it without the error out there? So, once you get the error, you'll have to click on open git log. In that git log, it will tell you what is the command you need to run. So, once you copy that command, run it out. That's when you will be able to resolve that particular error and then go ahead and commit it out. That will happen for the very first time because you did not set your user ID and you did not set your name. So that will happen for the very first time out here. So once you resolve that, you'll be able to do the commits. You'll be able to do a lot of things out here as such. Is anyone any more questions here? Anyone any questions that I can take? So we have a repository, we have a file, and uh, we are seeing, or we did see, how to do commits to that particular file using the, let's say, online, let's say on Azure Devops. And also we did the same thing. We downloaded the same file, or can I say we cloned the same file, or we cloned the repository into our local machine. And even in our local machine, we were using something called VS Code in order to do all our commits. And once we were able to do all the commits, we push that commit back into the Azure cloud. So clone is an operation, or git clone is an operation which will help you make a copy of your remote repository into your local system. Into your local system out here. You simply take your local system and make a copy of it, and you can also be using Git to track changes on your local system out here. So whatever change that you're doing on your local system, you can let Git track all those changes without even having to have an internet connection. Meaning, if you let's say go ahead, edit some changes, do some changes, and all those things out there, all those changes will be tracked by your local Git database, as we saw yesterday. This kind of a source control is called as a distributed version control mechanism, or distributed out here. Distributed version control mechanism. Example of a distributed version control mechanism is Git, wherein you can maintain multiple copies of your code in multiple systems. You can work on your local system and also track changes on your local system without having to connect to the central server, which is your remote repository out here. There is, or yes, there is one more mechanism out here which is called centralized version control mechanism. In a centralized version control mechanism, you won't be able to make changes on your local and track the same changes without having to connect to the central server. Meaning, you always need to have an internet connection. You cannot work offline. You always need to have an internet connection if you go for a centralized version control mechanism. Example of a centralized version control mechanism is something called TFVC, Team Foundation Version Control. Nowadays, Git is being used a lot. So you either use Git, Bitbucket, or let's say Azure repository, something like that. The centralized version control mechanism is not being used a lot these days. You do not, or we are not really using a lot of centralized version control mechanism. Earlier, we used to do a lot of centralized version control mechanism out here. And if you want to create a project, for some reason, if you want to create a project in a centralized version control mechanism, just a new project. This is how I create a project out here. I give a name of a project, I give some description. It's telling public and private. Then you have what? Advanced. Click on this. It's asking what kind of a version control you need. Git or team foundation version control, meaning distributed or centralized. If you are not able to decide, just click on this, that question mark. It will now take you to something else, which is just telling what kind of this one. Again, Git distributed. Git is a distributed version control mechanism. Each developer has a copy of the source repository. Developers can commit and set up changes on their local dev machines and perform such as history connection without a network connections out here. Whereas Team Foundation, each team member will have only one version of each file on the local. Historical data is only maintained on the server, meaning you cannot maintain the history of data in your local machine out here. The biggest difference between a distributed and a centralized version control mechanism, reason being, distributed is being used a lot, and also a lot of consumers are moving from TFVC to Git. There are a lot of migrations that are happening from TFVC to Git out here, and it's also giving you something like, if you have already have a TFVC repository, how you can migrate it using a tool. You'll have a tool out here, you can download that tool and migrate that entire repository. And also there are multiple differences that they give you out here. Need more to, let's say, make a choice, they'll tell you what is TFVC, what is Git, what are all these things out here, and so on and so forth. So what I want you all to do is just go through it, just go through this entire article telling what is TFVC, what is Git, and here you will be able to identify the differences between a distributed version control mechanism and a centralized version control mechanism. One of the interview questions that they normally ask. Let's go there also, and let's see if I did put the interview question out here. And that's what I asked with the very first question. What do you feel is the difference between a distributed control mechanism? What is, let's say, centralized version control mechanism? What category does Git come under? So the question of the interviewer can ask is that, do you think Git is a centralized, or do you think it's a distributed version control mechanism? If it's distributed, why do you feel it is distributed? What are the advantages of distributed over a centralized version control mechanism? Just click on this one. I'll take you to the same link telling what is let's say distributed and all these things. So this is how you have to read along with the classwork, telling, go through the, let's say, this page every day to see the class, and then let's say read that particular question out there as such. So now we are doing a distributed version control, and Git is an example. This is a Git based repository that we are using, which is called as Azure repos. Azure repos in the background is running something known as a Git, and the very first thing that we are doing is now called as what? A Git clone operation. That's how we start our journey with a Git clone operation. Simply clones out or simply makes a copy of the remote repository into your local machine, and you can start tracking all your changes out there. When you do a change on your local machine, and when you want to commit those changes to the remote repository, this operation is called as a Git push. So clone is from remote to local, push is from local to remote. So download and upload, the difference between download and upload, but please don't use download and upload terminology out there. It's Git clone and Git push. That's what we need to, let's say, use. And let's go back into our repository today, and let's understand one more thing out here as such. Let's come here into our repository, and let's see our repository. There is something called demo repository, and yesterday someone asked what is a repository. I said that repository is nothing like a folder in the cloud where you can start storing all your files and all your code and all that stuff. But let's hold there. One quick difference out here is that in a Git based repository, there is something known as a repository that you get, which is something like this, which is like a folder. In my case, there is a folder with the name called demo repository, something like this, wherein you can start storing all your files. But Git tells, hold on, before you store your files, you need to create at least one subfolder. I'm using a generic terminology telling subfolder, and that subfolder is known as a branch or branches. One Git repository can have multiple branches. As one folder can have multiple subfolders, one Git repository can have multiple branches within it. That's where I'm coming down to the concept called as branch out here. A branch. How do I identify a branch? Is that is that do we all know that this is the symbol of repository? This is a repository, and if you click on that repository, you can say add repository and so on and so forth. Inside that repository, do you now see something known as a branch here? Here, the name of the branch is called main branch out here. Anytime when you create a repository, the repository gets initialized with something called as a main branch out here. This is the first branch that basically gets created under your Git based repository. You can also see the same by going to the files, and here you have something called what? Branches. Here you have a branch called what? Main branch. Now, if I want to create a new branch, meaning I am a developer, I want to, let's say, go ahead and start working. I want to create a new branch out here. I'll say new branch. I can give the name of a branch like test branch, and very importantly, I need to say what is my parent branch. This is technically called as an upstream branch. It's called as an upstream branch, meaning if you're creating a branch, what do you want to base that branch out of? From where do I create that branch out here? That's what it is asking me. Using Azure Devops, meaning this particular dev.azure.com, you cannot directly create a branch without a parent. We call them as orphan branches. You cannot create a branch without a parent. You will have to tell what is a parent. For example, in my case, the only branch I can be selecting here is what? Main branch. I can say, okay, fine, great. Create this out. Now, test branch that you created is based out of the main branch. Let's open the main branch firstly. What do you have? You have, let's say, something like a readme.md file, and you have all these things, all these lines out here. This is inside what? Main branch. Let's go to the test branch. If I click on this, now I have what? Test branch. It also has the same content, no difference. What do you mean by this is very simple. Exactly, you are making a copy of this branch. You are just making a simple copy and paste of this particular branch out here. When you say upstream, the branch that will be created, which is a test branch out here in my case, will literally have the same contents what the main branch had. This operation is called as a branch pull. We say pull a branch. When you say pull a branch, it's nothing but create a new branch out of an existing branch. So tomorrow when you're working, your developer might be coming into you and telling that, you know what, can you pull a branch from main branch? I'll say, okay, fine. What is the name of the branch that you want me to name it? I'll go ahead and name this out. So we don't generally say create a branch. We say pull a branch. You can also optionally say create a branch. Not technically correct. It's just called git pull operation. It's called a branch pull operation out here. So your developer will say, can you go ahead pull a branch for me? Simple. Go ahead, create a new branch out there. So now I pulled a branch whose name is called as what? As a test branch out here. It's having the same contents. This is line 4. I will add one more line here. I'll say edit. I will say this is a new line on the test branch. Something that I'm doing. I will say commit. And here it's telling, okay, fine, give me a comment message. When you commit, give me a comment on what you're commenting out. I'll say this is a commit from the test branch, and I'll say comment this out. Now I have what? This is a new line on the test branch. My question for everyone is that on which branch did I commit? Test branch. So the version of the file has been updated in the test branch out here. Do you think that the same line will be getting updated in main branch also? No? Yes? No? Anyone who's yes? No? Let's try that out. Let's see. Let's go
No.
to main. No line. That's correct. Which means each and every branch will maintain a version of its own file. Each and every branch meaning will maintain a version of its own file, and also each and every branch will have its own history. If you click on this, this is a local commit which I did yesterday at 8:53 a.m. Before we close the class, I did a commit. What if I go to test branch? Look at the history of the test branch. Do you see this is a local commit is already there? Reason being, all this history was inherited from the main branch. Whenever you create a main branch, you not only create just a file, you also go ahead and give the entire history of the main branch out here. But on top of it, I have a new commit today telling this commit is on the test branch, which is just now. If I go into the commits again, I will be able to switch the commits between main and the test. Just telling you how, let's say, the commit is coming on, so on and so forth. Now, I want to take the changes that is there in test branch into the main branch. Exactly. Here, there is one simple change. There are two files. Here, there is, let's say, a new line. The new line is missing here. That's it. What Git will do when you want to take these changes is very firstly, it'll compare the two files out there. It'll say what is the one that is missing and what will be the change that I'll be doing out here. This is something that Git will compare. And let's go there into the branches. And once I go into the branch, do you see it's telling you updated something called test branch 2 minutes ago? Do you want to create a pull request? Very importantly, what it is telling is that if you want to merge one branch into the other, this operation is achieved by something called pull request, in short PR. We call them as PRs. We don't tell pull request and etc. in the real-time environment. We normally tell it's a PR, easier to, let's say, tell. So we tell PR. PR is nothing but a pull request. How do I create it? Is something like this. Straightforward way, you can come here, either click on create a pull request or go into repos. There's something called what? Pull requests. Click on this one. And now it's telling there are no active pull requests. Do you want to create one? I say yes, I want to create a new pull request. And now it is telling me between what is your source branch, what is the destination. I'll say source is test branch, destination is the main branch. As and when I did that, this is the commit message that I saved. Then I have files. If you look at the file right now, it's telling okay fine, in the main branch I am able to see that there is no line. This line will be added. This now basically will be added out here. I'll say okay, great. Let me go ahead and say create a pull request. Now the pull request is, let's say, created, and as and when the pull request is created, it's telling me complete, approve and all that stuff. I'll just say approve. I'll say complete this out, and you can optionally delete your branch after the merge is done. You raise a pull request to do a merge. You can uncheck this or check this out, and let's do a commit. And very importantly, even observe this, there is something called merge type. How do you want to merge? It's telling merge, no fast forward, squash, rebase and fast forward, semi-linear merge and etc. I'll put this in something called as merge, no fast forward. I will leave this open. I don't want to delete my test branch right now, and I'll say complete this merge. it's now telling merging your pull request, which means it's just taking all the changes from my test branch, sending it inside the main branch out here. And now if you go into the branches, and now if I go into main branch, do you see now I have a new line? And also if I go into the history of this particular file, do you now see that I have something called, this is the commit from test branch out here. I just took the same commit that was there on the test branch, and then this commit is also getting reflected out here as such. So all the commits, if let's say if you want to, let's say, take all the changes from one branch, move it to a different branch, you will have to move it through a pull request out here. And there are different types of merge, of course we'll talk about that, which is merge, no fast forward, squash, non-linear merge, and all these things. We'll talk about that. But the question here is that, can I achieve the same thing on my local machine also? Can I do the same thing on my local? Meaning, can I create a new branch? Can I go ahead with that? We'll talk about that in a minute. But before that, I'll take a quick pause and wait for any questions out here. Any questions that I can take? Mhm. We don't create any code, then why do you have to? Good question. That we don't create any code, but why do you have to learn about all these things? You don't create code, but you create PowerShell scripts, ARM templates, Terraforms, all these things which support the code. Even your ARM, Terraform, PowerShell, they have to store somewhere. Will be stored in the repository. If you have to store them in the repository, you'll also need to understand the underlying basics of Git. That's the reason we are doing it. So that's the reason we are coming to do Git out here.
Hi, Kiran.
Yeah, just a second. I'll just come back to you online. Just a second. I'll just say question offline and come back. Yes. Just a second. What is that? It's called. This is the pull request number. Every pull request will have a unique number out here. This is 109. Reason being, I did 108 pull requests before I started this class. Earlier demos, I was using the same thing. Sorry, sorry. It'll be 110. Yes, it'll be an ideal number. So each and every pull request will be, let's say, the number will come into picture as such. So I did about 100 pull requests earlier before I started this particular class. So you will have something known as a pull request out here as such, and each and every pull request will have its own number. Yes, Pawan, go ahead, please.
If we added in main branch some other line, it will reflected in test branch also.
Uh,
In test.
if we add a line, let's say in the main branch, will it be reflected in this branch also? Let's see that. I'll go into the main branch. I'll say this is a new line, or this is a line on main branch. I'll say commit. I'll say added a line on main branch. I'll say commit this out. The question here is that if I add a line on the main branch, will it be reflected on the test branch? Yes, no, maybe. You'll have to create a pull request. Exactly. Only then it will reflect. Each and every branch maintains its own version of the file. Until and unless you don't raise a pull request, these changes won't be reflected out here. So again, coming back to the earlier point, if you want to merge all these changes, pull request, new pull request. Now the destination branch is a test branch, source is a main branch, and then it's telling there are one file, two commits, and all these things out. I'll say okay, great, not a problem. I'll say this is a test pull request tr. I'll say create this out, complete it out, take a merge, no fast forward, complete this out as such out there. Again, if you see this right, if you would observe, there is no option to delete the main branch, because main branch is your default branch out there. If it is not a default branch, yes, you can delete it out, but main is a default branch in our case, so you cannot delete a default branch as such. And now do you see you have a PR 110, pull request 110, that went ahead and updated the test branch out here. So if I go into branches, go into test branch out there, now this is the line this is the line on the main branch is getting reflected. And if I go into the history, added a line on the main branch coming from a pull request called 110. The same history will be on the main branch as well. Added a line on the main branch, but there is no pull request because this was a direct commit on the main branch. This was a direct commit on the main branch. So using this, you will be able to identify whether this was a direct commit or did you commit it using a pull request. Does that answer your question, Pavan?
That's it.
Okay, so one Narendra is asking me that while trying to commit on VS Code, I'm getting an error. It's something like showing again error like command not found. While giving the command, it's showing command not found. Okay, can you please go ahead, give me the command, like send me the screenshot so that I can tell you why is it giving you that particular error, and I can, let's say, resolve it accordingly. Is any more questions here? Now, one of the advantages of committing using a pull request. Normally, when you work in an organization, the best followed practice is that don't commit something directly. Don't do a direct commit because a direct commit will, let's say, do more harm than a good. Commit using a pull request. Why do we recommend that? Let's see. Let's say that you have done some change out here, right? There is this line called this is a test line on, or this is a line on a test branch. We committed it on a test branch and then we did a pull request so that this line comes into picture here.